Section 4.4 is titled Permutations when objects are identical. Here are the key ideas we're going to be learning about. There are fewer permutations when some of the objects in a set are identical compared to when all of the objects are different. This is because some of the arrangements are identical. The number of permutations of n objects where A are identical and another B are identical and another C are identical and so on is P is equal to n factorial divided by A factorial, B factorial, C factorial, etc. For example, in the set of 4 objects A, B, and B, the number of different permutations P is equal to 4 factorial divided by 2 factorial times 2 factorial. This is because we have 2 A's and 2 B's. P is equal to 6, and there are the different combinations. Something you need to know. Dividing n factorial by A factorial, B factorial, C factorial, and so on deals with the effect of repetition caused by the objects in a set that are identical. It eliminates arrangements that are the same and that would otherwise be counted multiple times. Example 1. In the mountainous regions of India, China, Nepal, and Bhutan, it is common to see prayer flags. Each flag has a prayer written on it, and color is used to symbolize different elements. The colors are green, yellow, white, blue, and red. How many different arrangements of the same prayer can someone make if they use these 9 flags? 1 green, 1 yellow, 2 white, 3 blue, and 2 red. Let A be the number of arrangements of 9 flags. Then A is equal to 9 factorial divided by, I have 2 white flags, so that's 2 factorial, times I have 3 blue flags, so that's 3 factorial, times, and I have 2 red flags, so that's 2 factorial. Evaluating, we get that A is equal to 15,120 different arrangements. There's more than one way to skin a cat on these kinds of problems. Here's another problem where I don't use the formula at all. So, Julie's home is 3 blocks north and 5 blocks west of her school. How many routes can she take from home to school if she always travels either south or east? I drew a diagram that indicated the number of ways I could get to each intersection along the perimeter by just going south or just going east. Then I started to count the number of ways I could get to other intersections by going both south and east. So here I can go 1 way, 2 ways. So I have 2 ways of getting here. Here, for this square, I can go 1 way, 2 ways, or 3 ways. So this number is 3. To get to this square, I can get there 1 way, 2 ways, or 3 ways. So this square is 3. And then she noticed a pattern. Well, 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 3 is 6. And then she filled out the rest of her square with the pattern, using inductive reasoning. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. And she continued this pattern and filled out, and she ended up with 56 different routes from home to school, traveling south or east.